6.3 Trigonometric Equations 2. So basically, more trig equations to throw at you. We're going to be using other identities like half angle, double angle, and then we're going to be using some things that don't even have identities. And so how do we solve those? Alright. Solving an equation with half angle. So how do we know to use half angle? Right there, we see it. It's x over 2, theta over 2, a over 2, variable over 2. That's how we know it's half angle. So let's solve 2 sine x over 2 equals 1 over the period, or excuse me, over the interval 0 to 2 pi, and we're going to find all solutions. Alrighty, part A. So we're given an interval, but the interval we're given is for x, not for x over 2. The intervals you're given, it's always just for the normal value of x or theta or whatever. So we're given the interval for x, but we need the interval for x over 2. So we're just going to make the interval they gave us, we're going to make it x over 2. So the interval they gave us, it's technically 0 less than or equal to x, that's less than or equal to 2 pi, because remember that's interval note, so this is interval notation, this is set notation. So all we're going to do is just make it x over 2. So we're going to divide everything by 2. So our new interval is 0 is less than or equal to x over 2. That's less than or equal to pi. So the interval we're going to be working in is 0 to just pi. Now that we got out of that, out of the way, well, that was a tongue twister. We can go ahead and start solving this. So your first step is to find your interval, your true interval. So we have our function 2 sine x over 2 equals 1. Let's just go ahead and solve for x. So to solve for x, we'll divide everything by 2. And we're left with sine x over 2 equals 1/2. And we're going to leave it like this, because x, it technically is by itself. But you're going to find a different way that we can do this. So let's use the unit circle, just like 6.2, right? So we're going to use the unit circle to find where sine is 1/2. I know you're like, but we don't have just sine, we have sine x over 2. That's fine, just don't worry, we'll talk about the x over 2 at the end. So let's pretend that x over 2 isn't there, and let's just see where sine is 1/2. But be careful, we want to see where sine is 1/2 in the unit circle using the interval that we found. So remember, our interval is 0 to pi. So if you look between the intervals of 0 to pi, go ahead and figure out where sine is 1/2. It's 1/2 at pi over 2. My bad, pi over 6. I don't know why, I was looking at the 2 when I wrote that. Pi over 6 and 5 pi over 6. So at those two values, sine is 1/2. So we know that x over 2, whatever it is, we found, my bad, getting tongue-tied, x over 2 is pi over 6. We found that using the unit circle. And then we have x over 2 equals 5 pi over 6. Now we're going to finish solving for x. So if you would have done this, let me show you up here, do not write this. If you would have done this and solved for x exactly how it was, we would get sine x equals 1. and that's not going to give us all of our values. So that's why we don't use just x by itself. We wait until the end to go ahead and find out our true values. So let's go ahead and solve for x now, finally, and we're going to do that by multiplying. So we multiply, and we get pi over 3. If you're wondering what to multiply by, 2 over 1. So you would multiply everything by 2 over 1. And that's how you get pi over 3. And then same thing to the right side, we multiply by 2 over 1, and we get 5 pi over 3. And those are our exact solutions. Alright, let's find all solutions. To find all solutions, we need the period. My dog is upset, he can't be out here with me. So of the given function, we need to find the period. So the given function was 2 sine x over 2 equals 1. So remember, to find the period, it's a formula, 2 pi over b. So we have 2 pi over, and our b is here. Instead of x over 2, it's 1 over 2, though. We don't take the x with it, but remember, in front of every variable is a 1. And we simplify to get 4 pi. So that's our period. And remember, if we want to find all solutions, we're going to add 4 pi n to the values we already have. Because every time it makes a full, it starts to repeat itself, is at 4 pi. So we have pi over 3 plus 4 pi n, and then we have 5 pi over 3 plus 4 pi n, and it's where n is any integer. So every time you want to find all solutions, you just take the exact solutions and add them to the period n. So period times n, and that's it. Alright, more solving. So we're using double angle now. Now, how do we know we have a double angle? Really, ask yourself, look for it. Okay, you probably said it out loud. Oh my gosh, it's like Dora the Explorer. Alright. And, sorry, that realization, really blew me away, okay? When I pause, it's just like Dora the Explorer. I hope you say it out loud, because when I watch stuff like that with my niece and stuff like that, we say it out loud. Anyways, okay, back to math. Hopefully that lightened your day. Double angle, because we see 2x, 2 theta, 2a, 2 whatever, so 2 times something with our given function. So, if we look at each side, we have cosine 2x and cosine x. Now, I can't really solve there. I can divide by cosine x, right? So I could do this. Don't write this. Do not write this. So you probably thought, well, what if I do this? Well, that just leaves me with x equals 0. Do you think that that's every single answer? It's not. That's not every answer. We usually get a lot of answers, right? That's only one solution, so we can't just do that. Just like in 6.2, do not divide by functions. You're really wanting to try and switch the identities out. So do you notice that we actually have an identity? We have cosine 2x. So since we have cosine 2x, let's go ahead and switch that out. So remember, cosine 2x equals 2 cosine squared x minus 1. So we're going to switch that out. So we want to use identities. That's what you're going to try and look for. So where do I begin? Look to see if you can switch anything to an identity. Usually that's going to be your first thing to go to. So let's go ahead and switch that out. We have 2 cosine squared x minus 1 equals cosine x. And now, you see how there's a little 2 there? We have a quadratic. So since we have a quadratic, we need to factor. And since we need to factor, you need to set it equal to 0. So we're going to move this over. And when we do, we have 2 cosine, my bad, wrong color. We have 2 cosine squared x minus cosine x minus 1 equals 0. Now we're going to keep factoring. So just pretend like that's not there. Pretend it's 2x squared x minus 1. So pretend you have this and factor it. But when you factor, just go ahead and plug in the cosines. So we can factor this down into 2 cosine x plus 1, and then cosine x minus 1 equals 0. So actually, let me take that out again. So remember how we did the 2x squared minus x minus 1, how I said just treat it that way? So if you were to factor this, you would get x plus 1 and x minus 1. So all you need to do is just plug in the cosines with x. That's how you factor with trigonometric functions. Pretend that the trigonometric function's not there, and then you're factoring. Okay. All right, so with each factor, we're going to set it equal to 0. So we have 2 cosine x plus 1 equals 0, and cosine x minus 1 equals 0. All right, let's keep solving for x. We're going to subtract 1. So we have 2 cosine x equals negative 1. Divide by 2. So we get cosine x equals negative 1/2. Awesome. Let's do the next side. We're going to add 1 to both sides. So we have cosine x equals 1. And now we have our values. Now we need to use the unit circle to find the rest of them. But be careful because cosine is negative. Since cosine is negative, we're only going to be looking in quadrant 2 and quadrant 3 for that one. And then here, that is a special angle. So since we have a special angle, there's only going to be one answer. Alright, so for our special angle, we get x equals 0, because cosine 0 equals 1. And then for our quadrant 2, quadrant 3 values, so looking in those quadrants only, look to see where cosine is negative 1/2. Cosine is negative 1/2 when x is 2 pi over 3 and 4 pi over 3. So we have our solutions, 0, 2 pi over 3, and 4 pi over 3. Alright, let's keep going. Solving an equation using multiple angle identity. So we're given 4 sine theta cosine theta equals square root of 3. We want to solve that over the interval of 0 to 360. So do you notice now how we're actually not given an identity? 4 has nothing to do with our identities. Sine, cosine, they need to be squared. Square root of 3, that tells me nothing. But if you've ever taken me before, I've always said you can do whatever you want to your equation as long as you don't change the value. So I'm going to make this a double angle identity because I can, and you'll see how. When you're given a multiple of 2 reduced to a double angle, and I'll tell you how to do that. So how many times does 4 go into 2? 2 times. There's the 4. 2 times 2, there's the 4. Now I have a double angle identity. So I have 2 sine theta cosine theta equals square root of 3. See how I forced a double identity there? you're allowed to do that, because I didn't technically change the value, I just changed the way it looked. And that's the biggest thing I think in chapter 6 is we don't know where to begin. Start changing the way things look. Alright, so we know that 2 sine theta cosine theta equals sine 2 theta. So let's switch that. We have 2 times sine 2 theta, and that equals square root of 3. Let's just solve for theta now. So divide by 2. We have sine 2 theta equals square root of 3 over 2. And remember, we don't care that it's 2 theta, we leave it there. Technically, it's by itself. We talk about that afterwards, okay? Alright, our sine is positive. So since it's positive, when sine is positive, we're looking at quadrant 1 and quadrant 2. So let's look for values of sine that are square root of 3 over 2 in quadrant 1 and quadrant 2. So those values of sine in quadrant 1 and quadrant 2, so this is for 2 theta. We have 60 degrees, 120 degrees, 420 degrees, 480 degrees. Now, why did I go all the way to 480? What haven't we done yet? We haven't talked about our intervals. We haven't talked about our intervals, so we actually need to talk about our intervals. We're given the interval for theta. We need the interval for 2 theta. So the interval we're given is 0, x, 360. So what do you think we're going to multiply by? By 2. So our new interval is 0, x, 720. So that means we need to keep going in quadrant 1 and quadrant 2 until we are done with it, until we're below or up to 720. So if it's a 720, remember that's 2 rotations. That's why we have 4 answers. Now we have our solutions for 2 theta, so I need just theta. To get just theta, I need to divide everything by 2. So we have theta equals 30 degrees, 60 degrees, 210 degrees, and 240 degrees. So our solution set is 30 degrees, 60 degrees, 210 degrees, and 240 degrees. Alright, so same exact problem, but now we're doing it for all solutions. So the solutions we got for theta were 30, 60, 210, and 240. So if we want to find all solutions, we just need to find the period. So remember, the period is 2 pi over b. So actually, there's something easier for that. We can't find it that way because we're not working with just that function. Never mind. Excuse me. We don't use that formula. We're given it. We're given that period. So the period for just theta, we just half it. So half of 360 is 180. Also, doesn't that also work with our quadrants? It does. Alright, so that's the period that we're going to add to each of these values. So we have 30 degrees plus 180 times n. We have 60 degrees plus 180 times n. we have 210 degrees plus 180 times n, and then we have 240 degrees plus 180 times n. Alright, so example 5, we're going to solve tangent 3x plus secant 3x equals 2 over the interval 0 to 2 pi. Tangent and secant are related by the identity tangent squared x equals 1 minus secant squared x. And one way to begin is to try and make the given equation resemble the identity. So we're given the equation. Now we can kind of start to make it look like the identities. So pretend like that 3 isn't there in front of the x, just like before, how we pretend it wasn't 2 theta. Same thing here, and if we wanted to make it resemble, we see that they're squared. So secant and tangent need to be squared. So that's probably a good place to start, is to just square everything. Oh, my bad, getting ahead of myself. Let's back up. I don't edit these videos, so let's back up. We can make it look like the identity even more by subtracting secant 3x. My bad. Because I want it to look like number minus secant. So now we have tangent 3x equals number, which is 2, minus secant. Now we're going to square it. So we're going to square it to make it look like those little 2's. So we're going to force it there. So tangent 3x squared is tangent squared 3x. Do you notice we're only squaring the function? We actually don't square the number inside the function because the number is the angle itself when it's the tangent. So we only square the function itself, okay? Alright, next we square 2 minus secant 3x. So just bring it out and FOIL. So when we do, we have 4 minus 4 secant 3x plus secant squared 3x. Alright, awesome. Now we have it looking very similar to the identity. Tangent and secant is squared, but I don't know what to do from here because secant and tangent, they're not the same function. So if they're not the same function, how do I solve for x? Look at your identities. We know that tangent squared 3x is the same thing as secant squared 3x minus 1. So let's switch that to our secant. So we have secant squared 3x minus 1 equals 4 minus 4 secant 3x plus secant squared 3x. Now let's start solving for x. I'm going to subtract secant squared over. And you notice that they cancel out. So now we're left with negative 1 equals 4 minus 4 secant 3x. I need a lot more space. Sorry about that. I thought I gave myself a lot more space. I did not. Alright, let's keep solving for x. So I'm going to subtract 4 over. And when we do, we have negative 5 equals 4 secant 3x. We're going to divide by 4. So we have negative 5 over 4 equals secant 3x. Secant doesn't really do much for me. Secant 3x, that's not identity, that's nothing. So let's switch to cosine, because cosine we know a lot about. We know a lot about cosine. So remember, to switch it to cosine, we just take the reciprocal. And if we take the reciprocal of one side, we have to take the reciprocal of the other side. Oh my bad, that's a negative. That 4 was negative, so that turns to positive. My bad. So we just take that reciprocal, so positive 4/5 equals, and we just take the reciprocal of secant, which is cosine. Now that's not on the unit circle, and cosine 3x I don't know anything about. We tried, didn't work, but we want to keep it as our like 3 original, cosine, sine, and tangent. We want to keep our answers like that. So let's go ahead and find the interval. So our interval that we're given is 0 to 2 pi. But we're not working with just x, right? We weren't. We're working with 3x. So we need to multiply it by 3 to get our actual interval. So the interval we're now working with is 0 to 6 pi. Since cosine is positive, we know our answers are going to be in quadrant 1 and quadrant 4. So since cosine is positive, we're going to be working in quadrant 1 and quadrant 4. Alright, to find our answers, we actually need to use our calculators just like we did in 6.2. So I'm actually attaching, along with this video right now, I'm going to show you how to use your calculator. Because I realized I didn't show you in 6.2, so I'll show you now, but it's the same exact method. So I'm not going to write down all of the steps. I'll write down like the simplified version of all the steps, okay? So I'm going to do it over here, and I will show you after I write down the steps. So y1 should be your first function. The left side of your function. So tangent 3x plus secant 3x. But we don't have that secant button on the calculator, so we're going to switch it to 1 over cosine 3x. And then y2 is the right side. Alright, then our window. So it's always going to be 0 for your max, or sorry, your minimum. And then we have our x max, which is 2 pi. And 2 pi is approximately 6.3. Then we have our y minimum, which is -3, and our y maximum, which is 3. Y3, because of that 3 right there. That's the only reason why. And then we do the second trace 5. I'm not going to write down those steps because they're in 6.2, but there's your window and everything. Now I'm about to show you how to do all this, okay? Alright, so with our handy dandy calculator, you can download this. I sent you the instructions on how to download this for your computer, for your iPad, for your Mac, and this way you can always have a calculator with you, because I understand you probably, some of you rented a calculator. Alright, so the first thing we do is hit y equals, and then I'm going to input the functions. So we have tangent 3x, and then we close out those parentheses, plus 1 over cosine. So alpha y equals enter. We have 1 over cosine 3x. And then y2 is the right side of the equation, which was equals 2. Awesome. Now we hit window. So our x minimum is going to be 0. Our x max is about 2 pi, so 6.3. Our x minimum is -3, and our x maximum is 3. So now we hit second trace, and we want to find the intersect, so 5. We want our window to look like this because this is the interval in which we are working in. So you see how it intersects only 3 times? That means we only have 3 answers. So you see how it says first curve? You have to find them all on separate occasions. So I'm going to go to the far left one. So I'm pressing left until it's over there. It'll eventually get there, I promise. It will. Just keep pressing. There it is. All right, so you see how we're on the first intersection? So I'm on it. I'm on that blue line, so I press enter, and then it'll say second curve. It should pop up somewhere very close to where you're at, but it should be on the red line, and it is. Hit enter twice, so enter, enter. And then we get our first intersection of 0.2145004. That's our value, because that's what is x when y is 2. What is the left side when the right side is 2? Now we have to repeat it all over again. So we hit second trace, number 5. Let's go to the second intersection over here. So I'm going to use my right arrows. Just keep pressing. He'll get there. Oh. Oh. There we go. All right, close enough. So go ahead and hit enter. And then see how your second curve, it's already on the red one. So you're good. Press enter twice. So enter, enter. And we have our second intersection of 2.3088955. Now we have to do our last intersection. So second trace 5. There we go. All right, press enter. And then Y2 should already be on the red line. Press enter twice. Enter, enter. And then we have our last answer of 4.4032906. I'm going to write down all those answers for us. So we got our first one of 0.1, or my bad, 0.2145. I rounded it. And then we have 2.3089 and 4.4033. The last example about piano keys I took out of the test, I took out of the homework already, because we don't need to learn it, and as of right now, I just want to make sure you learn what you need to learn for the next class, okay? Alright, if you have any questions, just hit me up on Teams, email me. Honestly, a lot of you haven't joined Teams yet. I really suggest you should, because it's instantaneous. It's like instant messaging. We can also talk on there. We can video chat on there. So if you have a question, I could usually answer it like talking to you much easier, or using like, it's just like Skype. So sign up for Teams or email me. Let me know if you need any help before our first test, okay?